Data returned by the probe showed something very interesting. At high altitudes, the atmosphere of Venus is per day, a perfectly
No, it's
hospitable
12.
environment. But the lower the probe gets, the more extreme the climate becomes, not only ramping up in temperature, but in atmospheric pressure as well. Much like diving deep into the ocean, which is a strange concept to wrap your head around, the air is not only thick, but it's really heavy as well. It gets so bad that after 90 minutes of slow descent, transmission from the probe goes dead. It's widely believed
Close
that the
enough.
capsule
12:01, close
was simply
enough.
crushed like a beer can by the weight of the planet's atmosphere. With this new information, the Soviets were nearly certain that their remaining Venera 5 and 6 probes of the same design would have no chance of reaching the surface intact. But they launched them anyway, with back-to-back missions in January 1969. At this point in the decade, the Americans had already flown a crew into orbit around the moon and were preparing to take the first steps on the lunar surface. The Soviets knew they weren't going to be able to match that, but maybe if this Venus exploration works out and they can discover something amazing on the surface, then they might still have an achievement that keeps them competitive in the space race. But success would not come easy. Both Venera probes recorded less than an hour of data each before meeting the same crushing fate as their predecessor. And yet the Soviet Union was not discouraged in their efforts. They would simply build even bigger and even stronger probes, and they would try again. For their next round of Venera landing attempts, number 7 and 8, the Soviets made two key modifications to the probe design. For one, the descent module was now built with a thicker outer shell of steel to resist the atmospheric pressure. And two, the inside of the probe was reinforced with an internal sphere of titanium to protect instruments from the heat and additional padding around the sphere. To soften the blow from impact, which was a smart choice because when Venera 7's parachute deployed on August 17th, 1970, it didn't last very long. The material somehow got ripped or it just straight up melted, but either way, the landing module ended up dropping like a rock, reaching a terminal velocity of 61 kilometers per hour before bouncing off the
Wow.
surface. Based on that transmission, the observers back on Earth assumed they were looking at yet another failure to reach the surface alive. But this was not the case. Even with a busted up antenna, the lander was sending back information, and what Venera 7 found would confirm scientists' worst fears. The temperature recorded at the surface showed 75 degrees Celsius, or roughly 900 inside of a wood-fired pizza oven, and far too hot for any machine to operate reliably. And yet the Soviets were undeterred. At this point, what did they have to lose? The Americans had already planted their flag on the moon. That race was won. But the Soviets were still left with other opportunities to make their mark on history. They could be the first to make game-changing discoveries on Venus about the origins of life and the universe on Mars. This is the direction the Soviet Union would pivot with their space program in the 1970s, exploration. In 1971, they launched a probe that would achieve the first ever soft touchdown on the surface of Mars. The lander only operated for about 20 seconds before going completely dead, but it was still a major accomplishment. Then, in 1972, they would return to Venus yet again with Venera 8. Miraculously, this probe would not face any technical difficulties along the way. The descent module parachuted down softly onto the planet's surface, recorded data for nearly 1 hour. So by now we know that in addition to the extreme temperature, the air pressure on the surface of Venus is the equivalent of 92 times the atmosphere on Earth, which is the same as being 1 kilometer underwater. If that wasn't enough, the lower atmosphere is filled with sulfuric acid. That's the stuff inside a car battery. Now, you would think all of this confirmed knowledge would finally deter even, but the Soviet Union just didn't believe in quitting. Not when they were this close to cementing their legacy. So they aimed their sights right. Mirror 8 revealed too good fat side. Even with cloud cover, there was still enough sunlight reaching the surface. Photograph. Success. First ever picture. For Venera 9, the Soviets made a fundamental of the probe's design, and you can tell there's something different just by looking at it. The descent capsule itself has, of course, been beefed up yet again. We are now tipping the scales at nearly 5 known African elephant.
Wow.
But the standout features have to do with a new landing procedure. Given everything that they now know about Venus, the Soviets want to keep their probes exposed as minimal as possible, and they also learned that even after being dropped accidentally and plummeting hundreds of meters, the Venera 7 still managed to function. So, what happens if we just drop the probe intentionally? And this is what's going on with those two rings. Gear or impact ring, just a flat metal circle connected to the main body by a series of shock absorber. That is the new aero brake. Is how they Venus with no parachute required. That looks like a weird hat is all you really need to get the speed of the probe down low enough for a safe landing. That is putting the incredibly thick atmosphere of Venus to work because it actually behaves more like water than the air you've ever experienced. But what about those cameras? Well, this is the first photograph ever taken of Venus. It was captured on black and white film by Venera 9 in 1975. What we are looking at is a field of broken, jagged rocks surrounded by a sand-like material. It's not exactly breathtaking. The photo is only interesting because it was taken on Venus, but still very cool. And this is the view from Venera 10, an identical lander that arrived just a few days later. Now ground with hardly any of those chunks of rock, just the smooth top of what was probably once an ancient lava flow. Venera 11 and 12 were less eventful missions. They failed to return any interesting photographs due to lens cap failures. This was one of the tricks with Venus. You have to protect the camera on the way down, or it will melt prematurely, but then you have to rely on an automated system to reveal the lens. And it didn't always work. But then we get to Venera 13, an unlucky number, but a highly successful
81.
mission in the year 1981. This probe returned the first ever color photo of the Venetian surface. Again, the surface around the lander is just flat, sandy rock, but you can see just a touch of landscape beyond. The probe touched down near the edge of a cliff, so you can get a sense of depth that makes it all seem a lot more real and more alien at the same time. Anyway, you can also see the base of the lander again here, and you're probably wondering, what is the deal with those teeth? They look almost purposefully brutalist, but the teeth serve an aerodynamic function. Metal fins were added to the outside of the impact ring in an effort to stop the probe from spinning and shaking as it fell, which could lead to rough landings. But that's not all the Venera 13 could do. The probe was also equipped with a drill and surface sampler to analyze the Venetian soil. What it found was a material very similar to a rock that we call tuff on Earth. It's essentially just solidified volcanic ash. Oh,
Hmm.
and one more thing, Veneer 13 carried a microphone, so we can listen to the sounds of Venus. It's essentially just wind noise and the sound of the probe doing its thing, but again, like the photos, there's something very strange and alien about it. Veneer 14 was again pretty near identical. It found another flat plane of these smooth rocks, which were determined to be very similar to thallitic basalt, which is a volcanic rock that makes up most of the Earth's ocean floor. And that was it. That's the last time that a man made object reached the surface of Venus, and along with it comes the last photograph ever taken of the surface. But what I want to dwell on here is why we never went back. One very obvious reason would be that it's a lot of work and a lot of expense for relatively little payoff. You can send a robot to Mars and it'll last for years. The longest a Venera lander ever survived was about 2 hours. The Venera program came to an end right as the Soviet Union itself was coming to an end. Leadership and priorities changed. Russia went through a tough time in the 1990s. Meanwhile, NASA has just been too sensible to try and reach the surface of Venus. Trying to justify that cost to politicians when you get so little in return is not an argument scientists would easily win. So for now, the surface of Venus remains one of the solar system's greatest mysteries. So close, yet so far away.
Here, now you can. Over this DiGiorno wood fire style pizza with crispy, airy wood fire style crust. It's not delivery, it's DiGiorno. Old Flash Gentleman.
Phil.
Always been a gentleman.
DJ?
What's going on in there?
I'll be out in you.
Hours.
I think to put a little color up front, we're gonna add some headlight fluid of different flavors, varieties. I'm not really sure if it's flavors. I can always test.
This is Pluto, the ninth planet from the sun. Or at least that's what they told us in school. But then, in 2006, they changed their mind and decided that Pluto wasn't actually a planet anymore, and we should all just forget about it. They underestimated us. They underestimated Pluto. And luckily for everyone, a brave group of scientists were undeterred by the assault on Pluto's reputation, and in the same year that our boy was stripped of his planethood, NASA launched this probe, New Horizons, on a mission to investigate the object formerly known as Planet for the first time up close and personal. What they found was shocking. We were wrong about Pluto. The people in charge were wrong about Pluto. Everyone had gotten it wrong because it turns out that Pluto is so much more than we ever imagined. This thing might not be a planet, but it is one of the most vibrant and mysterious places in our solar system. Now, you might be asking, why did Pluto get demoted from its status as ninth planet in the first place? And as much as I want to say that it was a big conspiracy, it really has more to do with a constant change in how we identify objects in the solar system. And this has been going on for longer than you think. For example, back in the 1800s, when modern astronomy was really starting to kick off, there were like 20 planets in the solar system because every time someone spotted a new moon or even just a big asteroid, they would declare it a new planet. And at a certain point, this had to be reined in. So we started developing pretty strict criteria for what does and does not qualify as a planet. And this has been an ongoing process since then. In 1930, a self-taught astronomer and telescope maker named Clyde Tombaugh was hired to investigate the existence of a hypothetical Planet X. It was believed that there was something weird out in the distant solar system that was interfering with the orbits of Neptune and Uranus, some yet unknown planet. What Tombaugh found after 10 months of observation was a faint light moving slowly through space beyond Neptune. He had gone looking for a new planet, and by all accounts, that's exactly what he found. Even though the rules had tightened since the 1800s, there were still only two general criteria for planets in the 1930s. One, the object has to be in orbit around the sun. That's why moons don't count, because they orbit planets. And two, the object had to be unique in its location. That's why asteroids don't count. There are a bunch of them all in the same general location that all pretty much look the same. From what we could see at the time, Pluto fit the bill. It appeared to be the only bright object in the distant solar system. Unfortunately for Pluto, that was not the case. The big change came in 2006 when they updated the planetary definition to say that a planet must have enough mass to clear its orbit of other similarly sized objects, meaning that it needs to be the equivalent of a cosmic vacuum cleaner, absorbing all of the stray rock and dust as it passes by. A planet must be the master of its domain. And as it turns out, Pluto is not just going through some distant void out there. It's actually just one object in a massive cloud of stuff that has come to be known as the Kuiper Belt. It's like the solar system's junkyard. All of the stuff that didn't get pulled in to form the sun, the inner planets, or the gas giants ended up in a big ring around the outside. And Pluto isn't even the biggest thing in the Kuiper Belt. It's just the brightest thing in the area. That's why we saw it first and just assumed it was alone out there. Turns out Pluto is one of the most highly reflective objects in the solar system. The only planets with a higher reflective index are Venus and Jupiter, mostly because of their dense cloud cover. So from a distance, Pluto appears much larger than it actually is. However, Pluto doesn't spend all of its time mixed up in the Kuiper Belt. It's actually got a really weird orbit, a very dramatic oval shape that sometimes brings it much closer to the sun than Neptune, coming in pretty much equal to Uranus. In addition to that, the orbit of Pluto is tilted. Pretty much everything that orbits the sun is on a flat plane, like a disk. But Pluto's orbit is tilted 17 degrees relative to that disk. So it's almost always either above or below us. Not that we really notice because it takes Pluto 248 years to orbit the sun. So, because of all that, Pluto is definitely not a planet. But it is weird, and weird stuff can be really cool, which is the reason why the engineers at Johns Hopkins University built the New Horizons space probe to see just how weird this could get. And coincidentally,
Typical Ooh, I love these. The ones that you lit the fruity and fruitier. Yeah.
New Hyaluron Tint by L'Oreal Paris. Hydrates like a serum, lasts like a stain. You're worth it.
So, to recap, all the AI we're adding is supposed to streamline our workflows. But adding the AI to
Setbound. Watch this. Watch this. Setbound is the first to learn.
NASA launched New Horizon in the same year that everything changed for Pluto. The biggest challenge to overcome here was distance. Pluto is very far away, and you don't want to wait forever. So they took this relatively light New Horizons probe, which only weighed 1,000 pounds, and they put it on the most powerful rocket that was available at the time, which was an Atlas V that was strapped with an additional 5 side boosters, delivering around 2 million pounds of thrust. So New Horizons left the Earth in a hurry. In just 9 hours, it was already sailing past the moon. That's about 10 times faster than the Apollo missions. After just 1 year in space, the probe is approaching Jupiter. NASA uses this as an opportunity to test out the imaging system. New Horizons takes these photos of Jupiter and its moons, including this shot of an erupting volcano on the moon Io. But the real reason for passing so close to Jupiter is to use the giant planet's gravity as a slingshot to gain even more velocity and push straight on to Pluto. Now, this is still a long trip. Even with the gravity boost, it takes another 8 years to travel through the outer solar system. As New Horizons closes in on Pluto in 2015, it begins to take the first images. We see these two bright points of light in the distance that start to inch closer and closer as the days go on. That is Pluto and its largest moon, Charon. These two have an interesting relationship. Charon is around half the size of Pluto, and it orbits very close, just under 20,000 kilometers away. For context, our own moon is just under 400,000 kilometers out. This close relationship between two similarly sized objects creates a strange kind of tidal locking, where only one side of Charon ever faces Pluto, just like our moon, but also only one side of Pluto ever faces Charon. So if you were standing on the far side of Pluto, you would never see the moon. And if you were standing on the near side, you would always see the moon in the exact same place. Also, because Charon is so big, it doesn't actually orbit around Pluto. The center of mass between the two objects ends up somewhere in the middle. It appears more like they orbit around a point in empty space. That led some people to theorize that they circled around a mini black hole, but it's just gravity being weird. However, watching the cosmic ballet of Pluto and Charon was only the beginning. As New Horizons finally closed in, it began taking the first real photographs of Pluto's surface. And this is what it saw. If you were expecting a big blue ball of ice, this is not it. Pluto is a diverse mix of deep red, pale blue, white, yellow, and burnt orange. The first distinct feature identified in Pluto is this giant pale heart shape. It's created by low-lying plains of ice, and what's really interesting here is that each side of the heart has its own unique character. The side closest to the New Horizons camera is smooth and flat. We call this area Sputnik Planitia. For scale, this is about the size of Texas. And what makes this area so stunning is that it's unmarked by asteroid impact craters, which means that this is a region in constant change. The surface here is active, and any blemishes are quickly erased. Around the top edge of the heart, we see some really interesting patterns emerge. These lines are created by the movement of glaciers down from the highland mountains into the frozen plain. And this tells us that Pluto is not made of ice as we know it. Out here, far away from the sun, the temperature falls to negative 229 degrees Celsius. It is so cold that water ice would be too hard and brittle to form traveling glaciers. So what we've deduced is that the surface of Pluto is largely made from nitrogen ice. Our own atmosphere is nitrogen-based. It's the majority of the air that you breathe, and you're probably familiar with liquid nitrogen, that bubbling fluid that freezes anything on contact. Now imagine how cold it would have to be to freeze nitrogen solid. That is Pluto. Now, if we zoom into Sputnik Planitia, you can start to see these lines in the ice that form a variety of polygon shapes. Those lines are formed by convection currents, which is heat rising up through the surface of Pluto from its core. That heat
There's an
causes
ambulance.
the ice to melt, and only because
There's a big ambulance at the road.
of space, it's impossible for liquid to exist, even liquid nitrogen. So what happens is a process called sublimation, which is when a solid transitions directly to a gas. That gas rises up and actually creates an atmosphere over Pluto. It's not a thick atmosphere, it floats above the surface and forms into layers of thin fog, but it does extend very high up into space because Pluto has pretty minimal gravity to hold it down. The surface pressure on Pluto is probably around 1 million times weaker than on Earth, or at least that's the state it was in when the horizons flew by, which was during the time when Pluto was deep inside the Kuiper Belt. But we know that it moves on that really weird elliptical path, so there are times when Pluto is much closer to the Sun, and during those periods, sublimation will increase, and the atmosphere of Pluto could increase to as much as 1/4 that of Earth, which is 3 times the surface pressure of Mars and might even be enough to allow liquid nitrogen to form on Pluto. Turning our attention to another eye-catching surface feature of Pluto, that deep blood red stain that runs out from the left side of the heart. This region is commonly known as
Hey guys, what's up?
after
Just killing some
the
time.
horror of H.P. Lovecraft, although the technical name is actually Belton Regium. Either way, what makes it so red? The leading theory is that the color is being made by tholins, which are organic compounds created by radiation from the sun impacting methane and carbon dioxide that is lingering in Pluto's atmosphere. Once those molecules are thoroughly radiated, they come together, turn red, and fall down to the surface like radioactive snow. And you can see traces of that red splattered across the surface, which helps to illustrate that flow of ice, gas, and potentially liquid that carries the tholins around Pluto. Now, a less visible but equally as fascinating aspect of Pluto is its giant ice volcano right Mons. The volcano is about 5 kilometers tall and 150 kilometers wide, and it erupts with a slushy mixture of water and methane. This isn't Pluto's only cryovolcano, it's just the biggest, and we don't know how often these erupt, but we do know that the volcanic process here is still relatively active. For as wide as Right Mons is, there's only one visible impact crater on the whole thing, so we know this is not some ancient structure. It gets refreshed often, or at least relatively often on the cosmic timeline, so it might erupt every few million years or so. But where does the slush come from? Well, that's where Pluto gets even more mysterious. You might have been taught in school that this would-be planet was just a big ball of ice, but it's not. The evidence collected by New Horizons suggests that the core of Pluto is still hot, and that means below the surface there should be a thick layer of liquid water. This is the same composition that we expect to find inside the icy moons of gas giants like Jupiter's Europa and Saturn's Titan. We expect that the heat inside those moons is created by the powerful force of gravity coming from their nearby planets. We don't really have an explanation for where Pluto's heat comes from, though. In the early years of the solar system, everything was hot. It was like a cosmic dance party with a blazing young star surrounded by a dense cloud of
Hey guys, you have anything to say? Put the chat. I'll read it.
that was
We're just relaxing right now. It's spring break here in my area, so just killing time doing the videos for fun.
Utter chaos. But then everything started to chill out, and as far as we know, smaller objects tend to cool down faster than larger ones. And Pluto is very small, and it's out there in a very cold place, yet it remains hot on the inside. And then there's Charon. This is probably
Not sure yet.
best explanation for the general
I'm
strangeness.
just relaxing right now, watching
Because they are so
some history
similar in
stuff.
size, it doesn't make a whole lot of sense.
because I don't get spring break one, but yeah, not right. I'm not doing spring break.
They probably hit each other at some point in the distant past, and then instead of breaking apart or fusing together, they got caught up in this orbital wrestling match. The energy from that collision and the force of gravity between the two would have injected new life into Pluto. What's interesting is that the distinct heart shape on Pluto is located on the side opposite from Charon. That's probably not a coincidence. And you can see that same deep red tholin deposit on Charon, which is probably caused by ice volcano eruptions on Pluto that are violent enough to escape the weak pull of gravity and spray tholins out into space that eventually get pulled in by Charon and build up on its north pole. Sadly, these images that we've been looking at today will likely be the last photographs taken of Pluto in our lifetime. NASA has turned their attention to closer and more familiar locations in the solar system: Titan, Europa, Venus, and Mars. As a result, there's not even the beginning of a plan for a New Horizons Part 2. But there is still an amazing journey ahead for the original New Horizons probe. At the speed it was traveling, the encounter with Pluto lasted just a few days before it sailed clean past and headed deeper into the Kuiper Belt. Remember that Pluto is just the brightest and most visible object out there, but that doesn't mean it's the biggest or even the strangest. New Horizon is out there in uncharted waters, finding weird stuff, but that's probably a whole other video.
Bet you can't run as fast as T-Mobile. Bet you I can. But you gotta pick it up because T-Mobile now has the fastest 5G home internet. Watch this. I'm okay.
T-Mobile now has the fastest 5G home
Uh-huh.
internet. Just $30 a month.
I didn't watch the news today, so I wouldn't know.
Crispy, airy, light and charred at home. Magic. It's not delivery. It's DiGiorno.
Beneath the hazy orange clouds of Saturn's moon Titan lies one of the solar system's greatest mysteries. Out there is a world much like our own, something strangely familiar, but at the same time it is alien and unfathomable. For decades, the surface of Titan was hidden from our view until NASA found a way to cut through the haze and reveal the moon's true nature. This is what they found. Our first close encounter with Titan came in the year 1979 when NASA sent a robotic spacecraft named Pioneer 11 to visit the planet Saturn for the first time and investigate the rings and moons that surround the gas giant. We've known about the existence of Titan for centuries. It was officially discovered in 1655 by the Dutch astronomer Christian Huygens. It's not hard to spot either, as you can probably tell by the name. Titan is big. It's actually a bit larger than the planet Mercury, and it's 50% wider than our own moon, but it's still incredibly far away. So when Pioneer 11 first encountered Titan, scientists were eager to find out what it
Sometime in May. That's all I know. I think sometime in May.
Really able to see were the dense orange clouds that surrounded the moon. It was impenetrable. What Pioneer was able to do was investigate what that haze was made of, and it found something very intriguing: a thick atmosphere that was rich in nitrogen. This is very similar to what we have on Earth. The majority of our own atmosphere is also nitrogen. Now, there was another familiar discovery.
We'll see what happens.
Is what really piqued the curiosity of scientists: hydrocarbons. What are those?
We'll see when it happens, but it will be for a few more
They
months.
are carbon atoms bonded to hydrogen atoms. Most of us use hydrocarbons almost every day in the form of a combustible fuel like gasoline or propane. On Titan, the atmosphere is filled with methane, which we generally know as natural gas. Now, why is this important?
I don't know. Yeah, okay. If you work, I mean,
Well, a more practical
we'll see what happens.
explanation would
The
be
popcorn stand is not part of the zoo, but it's at the zoo. It's confusing, but yeah.
these carbon-based structures are also known as the building
So we'll see what
blocks
happens.
of life. Important molecules like DNA and protein are all built
I love you,
on
my baby boy.
hydrocarbon foundations. Here's a more familiar word for you: carbohydrates. Sounds pretty much the same, and it is, but carbohydrates bring oxygen to the party. So if we can find oxygen on Titan, then we've got more than just the building blocks of life. We've also got the food to fuel that life. And just so you know right now, there is oxygen on Titan, but we're going to need to go a lot deeper to find it. So stick with me. Flying a probe close by Titan was also able to give us a sense of the moon's gravity. And this is a bit strange because Titan has a lot less of it than you'd expect. For being so much bigger than our own moon,
Nope,
the
it's
force
too
of gravity
cold.
on Titan is actually a little bit weaker. Meaning Titan
I still got no grass.
Meaning it can't be made entirely of rock. And that opens up some interesting possibilities. The combination of a thick atmosphere and weak gravity means that a person in a wingsuit could essentially jump off a cliff and fly like a bird for as long as they want. It also makes a flying machine a perfect vehicle for exploring the surface. Writing clearly is hard, whether you're explaining rocket engines, sending an important email, or just trying to make your ideas come across the way you want. You write a line, read it back, and something just feels off. That is where Quillbot's Chrome extension comes in. With one click, it can rephrase your sentence to sound smoother while keeping the same.
No,
find it
I fixed it.
useful
It's a tall. The glass isn't tall yet.
So, say you're drafting an email to your boss or a client and you want to sound more professional. Highlight the sentence, hit Quillbot, and instantly see polished alternatives. Or maybe you're writing a school paper, a LinkedIn post, or even a cover letter. Either way, Quillbot helps you get your point across with clarity and confidence. The extension works right inside your browser, so you don't have to jump between apps or websites. Anywhere you're typing, Gmail, Google Docs, social media, Quillbot is right there to help. And if you want to try it out, check the link in the description to install the Quillbot Chrome extension for free. Once you start using it, you'll see how much easier it makes your writing, whether you're working on something technical, professional, or just day-to-day communication. So this is what
No, I always had to
in the 70s.
do something else. I had to replace a fuse.
Earth-like
That was easy to fix.
in the outer solar system. They knew that beneath the clouds of Titan could be a discovery that would change everything we know.
If I had
about
like a
life.
$2, like a dollar fuse, I had to change.
It was so close, yet
If I knew fuse in it, fired right up.
they would have
There-
to wait for
I'd probably jump box and it fired right up.
And 25 years later, in 2004, the Cassini spacecraft would finally arrive at Saturn to pick up where Pioneer 11 had left off.
I'm gonna pick up on my game.
Vital protein, solids, and peptides for healthy hair, skin, nails, and joints.
A century ago, our founders made a promise to always take care of their own. That promise is still at the heart of everything we do. And why we really know we'll do what's right. Because at USA, we take care of our own.
Oh, so if you want to do that too. There's a fuse I had to fix, which was easy to fix.
Oh, Saturday, you are simply glorious.
That's right, Max. No,
You wake us up with joy.
no matter what.
You bring us fans who play with players. Now that's what I call a team. So players of every kind. Oh, Saturday, you were made for soccer. This is why we do it on Saturdays. And now, with Walmart Saturday Showdown, you just became legendary.
This was a joint project between NASA, the European Space Agency, and the Italian Space Agency. Cassini is equipped with the necessary radar and infrared scanners
Yeah,
to see
sort
the
of.
dense atmosphere of both Saturn.
They're open now, but they're still damaged.
For this 13-year mission, the spacecraft would fly past Titan 127 times using its instruments to cut through the haze and investigate down to the surface.
It's not fixed yet, but it is open.
Was mind-blowing. Titan is the only moon in the solar system with an atmosphere, and this is a thick atmosphere, 4 times the density of Earth's. So what that does is it actually creates a reverse greenhouse effect, blocking out what little heat from the sun can actually reach this far. So as we move deeper towards the surface, all of the methane gas in the air gets colder and colder until it liquefies and falls like raindrops onto a surface of ice that is frozen as hard as granite rock. The average surface temperature on Titan is negative 179 degrees Celsius, and the freezing point of methane is negative 182. So it is the perfect environment to support a full hydrological cycle of evaporation and condensation, except with rocket fuel instead of water. The result is flowing rivers, lakes, and seas across the surface of Titan, making it the only known world aside from the Earth that has a stable liquid on its surface. Now, the people who built Cassini were very smart. They knew that Titan was going to reveal something incredible. So, the European Space Agency included a secondary probe, the Huygens lander, named after the Dutch astronomer who first discovered the moon. And it was designed to parachute down to the surface and take photographs of Titan along the way. In January 2005, Huygens began its descent. Based on images taken by Cassini, the target landing site was believed to be the shoreline of a small lake. The probe had been designed to survive landing on a variety of terrain, from mountain ranges to flat plains and even a liquid ocean. It had enough battery life to operate for 3 hours, with 2.5 of those hours being spent slowly parachuting down to the surface. And when Huygens finally broke through the clouds on Titan, this is what it saw. We begin to make out a dark valley set between brighter mountain ranges, and as we get closer to the ground, in the middle of the frame you can clearly see a network of drainage channels and streams that have been cut into the sides of the mountains. Some of these would be hundreds of meters wide and several kilometers in length. These would have been created by runoff from methane rains working their way into the valley. Huygens is coming down right into the middle of that dark area, and as it approaches the surface, we can start to see that there is no liquid here. It's actually landing in a dried up riverbed. When Huygens makes contact with the surface, it makes a dent 12 centimeters deep. It bounces and then slides about 30 to 40 centimeters across the ground before wobbling a few times and coming to a rest. As the camera begins to look around on the surface, the most striking revelation is not how alien the world looks, but actually how familiar this all seems. If you take away the orange color, it looks like the bottom of any river on Earth. We see large rounded stones that have been smoothed over by flowing liquid, and they're surrounded by smaller pebbles on what looks like a sandy surface. Only these aren't rocks. They are chunks of water ice that are frozen as hard as rock. Same with the mountains. They are made of ice as well. Remember, water means oxygen, H2O, but it's still no good for life if it's frozen solid. And the muddy-looking surface around the lander is thought to be a strange hydrocarbon material that scientists found to be very much like snow, with a thin, crispy crust on the top and a soft texture beneath. As the camera looks out into the alien landscape, you can start to see waves in the air. That is heat from the probe's lamp causing evaporation on the surface. At one point, we even see a small drop of methane dew drip down past the lens. As the camera pans up, we see the sun in the sky, and it's just 1/10 the size of how it appears from the Earth. And even though it's midday on Titan, the light is only as bright as what we see just after sunset at the twilight hour on Earth. So what Huygens found was pretty amazing, but it did fail to uncover the most intriguing mystery of Titan, the liquid methane. It seemed to land in the right place, the bottom of a river, but it just arrived at the wrong time. So where did the liquid go? One of the interesting findings from Huygens had to do with the moon's methane cycle. We know about the water cycle on Earth, right? Water evaporates from the surface and rises up into the sky where it condenses into clouds until there's so much water vapor trapped up there that it starts to fall back down as rain. In most places on Earth, rain happens pretty frequently because there's a lot of energy from the sun driving evaporation. But on the surface of Titan, where there's only a very small amount of sunlight, the liquid methane evaporates very slowly. And when it does evaporate, all of the methane vapor gets stored up in this incredibly dense cloud cover that can hold on to massive amounts of rain before anything actually starts to fall. The result of which would be long periods of drought that could last for hundreds of years at a time, followed by periods of torrential rainfall that would cause flash flooding all over the moon. So unfortunately, we did not visit Titan in its rainy season, but that doesn't mean that it was totally dry either. As Cassini continued on its 13-year mission, the spacecraft continued observing Titan and learning about its surface. What it found was that during the dry season, liquid methane is limited to the North Pole regions. And what the probe learned to spot were these bright reflections of sunlight shining off the tops of watery lakes. This is the first body of liquid methane identified on Titan. It's called Ontario Lacus, named after Lake Ontario in North America, because the two have a nearly identical shape. Only the one on Titan is about 20% smaller, but it still covers about 15,000 square kilometers. Even though the lake is pretty big, it's actually still relatively shallow with the average depth between 40 centimeters and 3 meters. It's also an eerily still lake with waves only reaching 3 millimeters in height. So, to the naked eye, the surface would appear as flat and still as glass. Now, we're not sure why that is. Given the higher air pressure and lower gravity, waves should actually be bigger on Titan than they are on Earth, and Lake Ontario has some pretty big waves. Titan even has a small ocean at its north pole. This body is known as Kraken Mare. It's 400,000 square kilometers in area, just a bit smaller than the Black Sea on Earth, large enough that it actually experiences a tide from the gravitational pull of the nearby planet Saturn, with the liquid methane rising and falling up to 1 meter. Although Kraken Mare is still relatively shallow for its size, around 300 meters deep on average, while the Black Sea reaches down over 2,000 meters. But lakes and oceans of methane are not the only active process still happening on Titan. There are volcanoes as well. Only we know that the surface of Titan doesn't have rock. It has ice that looks like rock. So the volcanoes don't erupt with magma, they erupt with slushy water. Now, if Titan is so cold, then how is there any water that isn't already frozen solid? Well, the slush magma is mixed with ammonia, which acts as a natural antifreeze. You probably know ammonia as a foul-smelling cleaning product, but it was also very abundant during the formation of the solar system. It's just a combination of nitrogen and hydrogen, two of the most abundant atoms in the universe. And it ended up getting mixed into the composition of planets and moons, and then played a huge role in shaping those environments. So any ammonia on the surface of Titan would have evaporated and helped to create the nitrogen-rich atmosphere, and any ammonia below the surface would have combined with water ice and allowed it to melt into various liquid forms. So if we looked at a cross-section of Titan, we have a solid crust of frozen ice. Then below that is a layer of partially frozen slush that occasionally erupts out through volcanoes, and below that slush is where we believe that a thick layer of liquid water still exists on top of the moon's rocky core. There's just enough residual heat and ammonia to maintain a subsurface ocean. So we have our water and we have our hydrocarbons, and we know that by combining the two, we get carbohydrates, which is the fuel for life. And we also know that through this active volcanic process, there is an opportunity for the two elements to meet each other, either above or below the frozen surface. So we're not saying that there are aliens up there, but there is the opportunity for some primitive bacteria to form that would meet the bare minimum criteria to be considered alive. And that is why NASA is currently investing hundreds of millions of dollars in their return to Titan with a mission called Dragonfly. This is a nuclear-powered helicopter drone that is designed to fly around the landscape of Titan and collect samples that will be analyzed by a mobile laboratory inside the vehicle. The plan is for Dragonfly to launch in 2028 and arrive at Titan by the year 2034. This will be a complex mission, but it's the only way for NASA to solve the mysteries of Titan. We'll find out what that sandy, snow-like surface is actually made of, and if there are signs of life out there, then Dragonfly will be our best shot at finding it.
Ooh, I love these. The ones where tulip, the fruitier and fruitier it gets. Oh, I'm gonna sit this one up. It tastes too good.
Old Splash Gentleman. Guess I've always been a gentleman.
DJ,
Ron, what's going on in there?
I'll be out with you.
Beneath the hazy orange clouds of Saturn's moon, Titan lies one of the solar system's greatest mysteries. There is a world down there, much like our own, something strangely familiar, but at the same time, it is alien and unfathomable. So, of course, the only way to know for sure what's actually going on out there is to land on the moon and investigate for ourselves. This is exactly what NASA will do with their upcoming Dragonfly mission, a nuclear powered helicopter that will fly on Titan and search for alien life. What we do know about Titan is awe-inspiring. It's the only moon in the solar system with an atmosphere, and this is a thick atmosphere, 4 times the density of Earth's, and just like on Earth, the majority of Titan's atmosphere is made of nitrogen, but very much unlike the Earth, where we have a nice mixture of breathable oxygen, Titan's atmosphere is laced with methane, more commonly known as natural gas. And that thick atmosphere actually creates a reverse greenhouse effect, blocking out what little heat from the sun can actually reach this far. So as we move deeper towards the surface, that methane gets colder and colder until it liquefies and falls like raindrops onto a surface of ice that is frozen as hard as granite rock. The result is flowing rivers, lakes, and seas of methane flowing all across the surface of Titan, making it the only known world, aside from the Earth, that still has an active hydrological cycle and stable liquid on its surface. Also, like the Earth, Titan has a variety of environments. In addition to the rocky seashores, there are vast deserts across the moon's equator with long dunes formed by blowing wind. Only this is not sand. It's a granular organic material that's also fallen from the sky and settled on top of the frozen ice rock. We have no solid answer as to what this material is, or where it comes from, or if it could potentially support some signs of life given the right circumstances. And speaking of life, Titan has water, lots of it. There is a liquid ocean of water beneath the surface that's mixed with a lot of salt that prevents it from freezing. And occasionally, water will erupt out onto the surface like slushy lava from a cryovolcano. There are also very few impact craters left on Titan, which means that the moon's surface is in a constant state of change and renewal, just like the Earth. So when we put all of this together, water, nitrogen, carbon, and organic molecules, we get all of the right ingredients for life as we know it. Only the environment on Titan would suggest that life couldn't possibly exist here, not as we know it at least. But we also accept that there is still a lot about the universe and the nature of life that we don't know. So we hope that our journey to Titan will return new answers. Now, this is not the first time that we visited the remote moon of Saturn. Everything that we think we know about Titan comes from the Cassini probe that was launched to Saturn in 1997 and studied the planetary system from orbit for many years. But Cassini also brought along a very special bonus payload, a lander called Huygens, named after the Dutch astronomer who first discovered Titan in the night sky. Because of the thick haze that surrounds the entire moon, it's impossible to study Titan from a distance. We need to get up close and personal. Cassini drops Huygens over Titan, and the lander begins to fall into the atmosphere, which is not only very thick, but also very high. We used to think Titan was a lot bigger than it actually is, hence the name, because it's bulked up by so much atmosphere. And after deploying its parachute, Huygens spends 2.5 hours floating down to the surface of Titan. It was able to capture these images after finally breaking through the dense haze and coming in for a landing. Remember, these are photos taken with a digital camera from the mid-90s and were transmitted live to Earth over 1 billion kilometers away using the Cassini probe as a relay. So unfortunately, the quality isn't fantastic, but we can see the cliffs of icy rock that have been cut through by flowing streams and rivers of liquid methane. Huygens lands in the soft, sandy bottom of a dried up riverbed. The last thing it sees before shutting down are these rocks, smooth and rounded by erosion, just like river stones on Earth. Only this isn't rock, it's solid ice.
Not just anyone who fight for everyone. Marines are made for this.
This product contains nicotine. Nicotine is addictive chemical.
every check, the General gives you a break to keep you covered. Whether it's on your car insurance or a break from your car accident.
I save lives. And my children are left out.
The General's got you covered. I hope you enjoy this. For a great low rate, go with the General.
So of course, we have to return to the surface of Titan to find out more. And this is why NASA has developed their Dragonfly rover. It's not like any rover that we've seen before. This one has more in common with a modern quadcopter drone. The only other extraterrestrial location where we've actually flown anything is Mars, which has 37% the gravity of Earth and less than 1% the density of atmosphere. So the fact that NASA was able to fly their Ingenuity drone at all was a pleasant surprise. And Ingenuity was able to complete 72 flight missions on Mars in 3 years of operation. During that time, NASA was able to learn a lot about flying drones from millions of miles away, and they're currently transferring all of that knowledge into the Dragonfly project. Only this time, they're going much bigger. And a bigger drone requires a bigger power source. While Ingenuity was able to get its energy from a small solar panel, Dragonfly will be too far away from the sun and sheltered under too much cloud cover. So to explore Titan, NASA has to go nuclear, which is the same power source that they've been using for Mars rovers since Curiosity back in 2011. This isn't a nuclear reactor like what you may have seen in a power plant. These deep space explorers use a radioisotope thermal generator, which is basically just a chunk of radioactive plutonium that generates heat as it decays, and the generator converts that heat to electricity. Dragonfly is just over 3 meters in length and weighing in at around 450 kilograms. On Earth, that is. But due to the relatively small size of Titan, the gravity there will only be 14% as strong. That's very close to the gravity of Earth's moon. And when you combine that low gravity with a thick atmosphere, it makes flying on Titan a very easy and efficient way to get around. Dragonfly is also an octocopter with 8 propeller blades, each a little over 1 meter in diameter. This design allows for a level of redundancy. The machine doesn't actually need 2 propellers on each corner to fly, but this means that if one breaks, the mission won't be grounded. And that's important because this is a very long and expensive endeavor for NASA. Dragonfly has been in the works since 2017, and it's actually an evolution of an older plan that would have sent a balloon to float around over Titan. As with most complex space exploration missions, timelines can be difficult to pin down. But Dragonfly does have a launch window set for July 2028, and NASA has already booked the SpaceX Falcon Heavy for the job. Now, getting all the way to Titan in a reasonable amount of time is not going to be easy, even with a launch vehicle as powerful as the Falcon Heavy. So, what they're going to do is launch the probe out to Venus first. Then Dragonfly will slingshot around Venus using the planet's gravity to gain momentum. Then it actually comes back to Earth and performs another gravity assist slingshot to gain even more velocity. And then Dragonfly actually sets course for Titan. This whole process should take 6 years. Dragonfly will arrive at Saturn 1.2 billion kilometers away from the Earth in 2034. The final approach to Titan will be a direct ballistic entry, meaning the vehicle won't settle into orbit and then gradually descend. We are hitting Titan like a cannonball. After separating from its cruise stage engine, the entry capsule is basically just a heat shield with a dome-like cover on top. The heat shield used by Dragonfly is going to be very similar to what NASA used when the Perseverance rover landed on Mars in 2021, and the heat phase of entry should last for about 6 minutes. That's the first moment of stress. Then again, just like with a Mars rover, once the probe has entered Titan's atmosphere, a supersonic drogue parachute will deploy to start bleeding off velocity. This phase should be pretty easygoing. Dragonfly will spend 80 minutes descending on its first parachute. Then, once we're moving at a comfortably slow pace, the heat shield will be ejected and the main parachute deploys. The final descent phase lasts for another 20 20 minutes. Now, at 1.3 kilometers above the surface of Titan, things get stressful again, because Dragonfly won't be landing with its parachute. Keeping in the same profile as the recent Mars landers, Dragonfly will cut loose from the parachute and deploy its own propulsion system. On Mars, this has been rocket engines, but on Titan, it will be propellers. So it's trial by fire for this drone. Either it works right off the bat, or it drops like a rock. But assuming that it does work, Dragonfly will hover down for a soft landing on the surface of Titan. The chosen landing zone is in a region named Shangri-La. There's a reference to a fictional location in the Tibetan mountains from a 1933 novel called Lost Horizon by the author James Hilton. Interesting choice, given that this region of Titan is more like the planet Arrakis from the Dune series by Frank Herbert. Dragonfly will touch down on a flat plain flanked on both sides by gigantic windswept dunes. These dunes are on average 1 to 2 kilometers wide, 100 meters in height, and they stretch on for hundreds of kilometers. The sand on Titan isn't made of silicates like we know on Earth. It's actually solid hydrocarbons that fall from the sky. So it's kind of like a very hard, grainy snow, if that snow was made from gasoline. Since carbon is the primary building block of life as we know it, these carbon-based grains are considered to be organic compounds, which doesn't mean they are alive, but it means that they might become alive if given the right set of circumstances. What exactly those circumstances are is still largely uncertain, but if these organic compounds are mixing with the subsurface water on Titan, then there could very well be something alive down there. Anyway, that's the first thing that Dragonfly will be investigating. The drone might travel by air, but its most important science will be conducted on the ground. Dragonfly's primary instrument is a drill that will cut into the surface to break up the frozen ground and create a loose dust that can be inhaled into the drone like vacuum cleaner and transported through a series of tubes into a sample collection device. Every time Dragonfly takes in a sample, it is stored in an individual small container. That container is then transported internally over to a device that will basically shoot the sample with a laser to break the material down into its individual molecules so they can be identified. Then, if the collection of molecules in the sample turn out to be particularly interesting, the container is transported to an oven inside Dragonfly that vaporizes the molecules into a gas that can be even further broken down, sorted through, and analyzed for its specific chemistry. What scientists are looking for specifically are biosignatures. That would be signs of very primitive bacterial life. The idea here is that the conditions we see on Titan right now are very similar to what we believe the conditions of the early Earth were like, where hydrocarbon material fell from the sky and combined with water to form the primordial soup from which all life emerged. That's the theory, at least. So, to conduct this research, Dragonfly will spend 3 Earth years, or 764 Titan days, hopping across the surface, flying over dunes, and landing in the valleys between them. Dragonfly is expected to travel over 180 kilometers and explore 24 unique sites. Dragonfly will lift off once per Titan day, which is every 16 Earth days, traveling in the light and then setting down to collect samples and analyze them until the next dawn. This means the majority of its time will be spent on the surface, taking measurements and transmitting data back to Earth. While the mission begins among the desert's sand dunes, the probe's final days will be spent investigating a large crater known as Selk, where it's believed that organic compounds were able to mix with liquid water following an asteroid impact that broke through the ice barrier. The one place of interest that Dragonfly will not be visiting is the methane seas. In fact, it's unlikely that the drone will encounter any of the surface liquid at all. And that is disappointing. But there's a good reason. It's believed that at one point in time, most of Titan was covered by rivers and lakes. But over the course of billions of years, the surface liquid has retreated almost entirely to the moon's north pole. That's where we would have to go in order to find it. And unfortunately, Landing at the polar regions of a planet or moon is about the hardest thing that you can possibly do. We are still really struggling just to land at the south pole of our own moon. So, trying the same operation 1 billion kilometers away on Titan would be too much of a risk. Going that far and then crashing would be a disaster for NASA. Landing at the equator is the simple answer, and with a mission of this scale, simplicity is the key to success. It's not like Titan is going anywhere. You don't have to do all of the science all at once. In a decade from now, who knows what scientists and engineers might be capable of? We'll have new technology, new rockets, more capabilities to send even more amazing machines out into the deep solar system and discover things that we never even dreamed possible. The Dragonfly is really an amazing first step towards extending our reach far beyond the Earth, and that is something really cool to look forward to.
Men don't do basic hydration. We need super hydration. Old Spice super hydration. Vitamin booster for 24/7 healthier looking skin.
Beta? Are you using all the old plants?
Oops. Sorry. We're all out.
There's more to explore with Seaboard in the Mediterranean, with tucked away pools, fresh exploration, and exclusive access events for you. Luxury meets exploration.
We are going to the moon, and we are going there to stay this time. That's the plan that the American government and dozens of their international and commercial partners have made. And assuming that they can stick to that plan, what we are looking at is so much more than just landing people on the moon. Landing is not easy, but it's also not the hardest part. We have done that before. But what comes next is something entirely new. We need to build on the moon. We need to build a permanent base on an alien world. And no one is exactly sure how we do and innovative new solutions for life. First, we need to talk about where the base is going to be located. The moon is a big place, and every previous human landing has happened right around the middle in a nice, flat, safe location that was very easy for direct radio communication with the Earth. But that was the 1960s. And this time, when we return to the moon, we are aiming for a much the lunar South Pole. This region is littered with impact craters, mountain ranges, and ancient volcanoes. Some of the low valleys and crater beds are in permanent shadow. The ground hasn't seen sunlight in millions or billions of years, and it's probably full of water ice that was transported to the inner solar system on asteroids and comets. NASA has identified 13 potential landing sites for the Artemis program. They are mostly on little patches of sunlight around crater rims or the tops of low mountains, surrounded by deep shadows and rough terrain. This will be a deeply fascinating region for scientific discovery, but it will be equally as dangerous for the people who need to live and work on the moon for weeks and months at a time. So this is going to require infrastructure like we've never seen before. All of the fundamentals for a city on Earth need to be recreated in the most hostile environment with the most limited resources. So, where do we begin? With roads. Yes, where we're going, we do need roads and landing pads and other solid surfaces to create and build on. That needs to be solved is dust. The lunar surface is a thin, yet incredibly light and fluffy layer of ultra-fine dust. Each grain of this moon sand is sharp and abrasive like broken glass. During the Apollo missions, it was known to cut through the outer layers of spacesuits and scratch the glass on the astronauts' helmets. To make matters worse, the dust is also clingy. Dust accumulation on the lunar roving vehicle caused it to overheat by clogging up the radiator. The trick is that without atmosphere and with very little gravity, once you kick up dust, it can really travel. When Apollo 12 landed on the moon, they tried to get as close as possible to a probe called Surveyor 3 that had already touched earlier. NASA wanted astronauts to go check in on it, and what they found was that even though the Apollo spacecraft had landed 180 meters away, Surveyor had been sandblasted by dust that the lander's rocket engines had picked up. So if we are going to build a moon base where people are constantly landing and lifting off and driving vehicles and walking around, then we need to do as much as possible to eliminate dust from our lives. That means roads and landing pads and hard surface areas around our base camp. The quick and dirty answer in the short term could be rhino snot. That's a nickname that the US military gives to a spray-on product that they use to stabilize their roads and helicopter landing pads out in the field. It was popular in Afghanistan for turning desert sand into solid material. They found it particularly useful for eliminating dust clouds created by helicopter takeoff and landing. So that's a potential solution for the short term. It's not ideal because we have to transport all of this rhino snot material from the Earth, and we are basically polluting the moon, filling it up with microplastics. So a more sustainable answer that can actually be scaled up to build a small city on the moon would be to just melt the surface into solid glass. This is something that the European Space Agency is working on right now with an experiment called PAVER. Scientists have been using simulated moon dust and a powerful laser to experiment with melting the dust into a solid glass-like surface. This is an idea that kind of dates back to 1933 when people thought that you could pave roads through the deserts of Earth just by melting the sand. Makes sense, right? Glass is just melted sand. The idea was wildly impractical for that time and place, but in a future moon base, it might be the best option we've got. Now, we probably don't have to bring a giant laser to this. Instead, what we could do is set up a big magnifying glass to concentrate the sunlight. Specifically, they use something called a Fresnel lens. It concentrates light using grooves carved into a flat piece of clear plastic. So it eliminates the need for a big curved piece of glass. And a Fresnel lens would only need to be just under 2.5 meters wide. But given the geography of the lunar south pole, where the sun is low on the horizon and the shadows are long, we might just need lasers as well. Either way, this would be a slow process. The Europeans working on the PAVER experiment estimate that we could make a 100 square meter landing pad with a thickness of 2 centimeters in 115 days. That is something like 100 times more slowly than paving roads with traditional asphalt. So it's a big job, but we are going to spend a lot of time driving. Our primary transportation will be pressurized rover vehicles, like this one being developed by the Japanese space program in partnership with Toyota, also known as the Lunar Cruiser. Rovers like this will be how we move around the moon base without having to constantly be getting in and out of spacesuits all day. You move directly from your pressurized habitat to your pressurized rover and then onto the next building. This is the wild. Lunar Cruiser is essentially an RV for the moon. It can support 2 astronauts on a road trip that can last for 30 days or more and would be powered by a hydrogen fuel cell. Now, having an RV is cool and all, but where do we live? Well, we need to break that down into short-term accommodation and long-term. Building a moon base is not going to happen overnight, and NASA has already designed our first lunar house. They call it the Foundation Surface Habitat. It's a 3-story structure that combines a metal frame with an inflatable module and will support up to 4 people over a time period of about 1 month. Although the foundation will mostly be occupied by 2 astronauts, while the other 2 crew members are out exploring the moon in their pressurized vehicle. The ground level of foundation is a metal structure that will be 4 meters in diameter. It contains the airlock and EVA suits, plus a science station for geological experiments with lunar samples. Astronauts climb a ladder to reach the second level in the inflatable module. This expands to 6.5 meters in diameter. This is also where we'll find the hygiene and exercise equipment. There's also a biology lab where astronauts will study the effects of the lunar environment on plants and animals. Going up to the 3rd level is the primary living space for the crew. There are beds, a medical station, kitchen, and computer workstation. There is also a human research lab where astronauts themselves become the guinea pigs in a study of how long-term habitation on the moon affects the human body. Now, if we can get past the foundation period, then we need to start building permanent structures on them, something that provides a level of protection and security. We need to insulate ourselves from the dangerous cosmic radiation, mitigate the effects of the wild temperature swings between the lunar day and night, and also protect it from meteorite impacts. To accomplish this, we go back to the beginning of human architecture. We build with bricks. In the same way that scientists believe we can melt the lunar surface to create glass roadways, they also think we can bake moon dust into structural bricks. The idea is that we could still use something like an inflatable habitat or even a solid metal structure, but then we encase it in a shell of brickwork. This should mitigate most of the dangers from radiation and micrometeorite impacts, while providing an insulating layer to make heating and cooling the habitat more efficient. China has already begun testing their own moon bricks. Their idea is to build this egg-shaped structure called the moon pot vessel. Construction would be done by robots and incorporate traditional Chinese construction techniques with bricks made from lunar soil in addition to 3D printing. In 2024, China began an experiment to create bricks from 5 different simulated lunar soil compositions and tested 3 distinct methods for heating the soil into solid rock. Then, in November, they transported those bricks to the Tiangong space station, where they were placed on an external experiment track. The bricks will spend the next 3 years being exposed to the vacuum of space, cosmic rays, and large temperature changes to see how well they hold up. There's also this wild concept of combining glass melting and habitat construction into a giant sphere structure on the moon. This looks insane, but a US company called Skyports has received funding from the NASA Institute for Advanced Concepts to develop the idea. What they do is basically just glass blowing on a large scale. You heat the moon dust until it becomes a molten glue, then you use compressed gas to blow it up into a big sphere. Since there's no atmosphere and very little gravity, you wouldn't actually have to blow very hard, and the structure could grow to humongous sizes without collapsing on itself. Then, to add more protection and insulation, you could blow multiple layers of glass with air gaps in between, kind of like a multi-pane window. Probably not the most practical idea, but it's pretty neat. Either way, none of this is going to work without power. So, where does that come from? Well, there's the sun. We all know that one. Both lunar missions to date have been mostly solar powered, and that's worked well enough. But there's a big problem with solar energy on the moon. Because the moon rotates so much slower than the Earth, it ends up with this very long day and night cycle. 2 weeks of sun followed by 2 weeks of darkness. That was never a problem for human missions because those guys were only ever up there for 3 to 4 days tops. But when we send an autonomous lander or rover with solar power, they are only able to work for 14 days. Then they freeze solid for the next 14 days, and most of them just never turn back on once the sunlight returns. Even if they do, they don't work the way that they used to before the sun went down. Now let's flip back to our map of the 13 potential Artemis landing sites. Check out all of those shadows. Most of those areas are in permanent shade. Sunlight never gets in there. And those are the locations where we are most certainly going to find the water ice that we need to sustain our moon city. So the answer is to go nuclear. Nuclear power in space is not exactly new. China has been operating a nuclear-powered rover on the far side of the moon for a few years now. NASA has been using nuclear rovers on Mars for over a decade. Their Voyager probes from the 1970s are also nuclear powered. But these are all very small-scale operations. These generators use the heat produced by naturally decaying radioactive material and convert that into a few watts of electricity. It's fine for a robot, but you cannot scale that up to something that would power an entire lunar base. We need a nuclear power plant on the moon, and that's exactly what NASA has been working on for several years now. They call it the Fission Surface Power Project. This uses the same fission reaction that is standard at all nuclear power plants on Earth. You split atoms of uranium fuel, which release tremendous amounts of energy that manifests in the form of heat. In space, where there's no water to boil to drive a steam turbine, we can use something called a Brayton converter to turn heat into electricity. It's pretty complicated. I wouldn't worry too much about how it works. It just does. And one of the advantages to those shadowy craters that never see sunlight is that we can just put a nuclear reactor down in there and it will never overheat. The trick is that these reactors have to be small. NASA specifies that the weight needs to stay under 6 metric tons and it can't be any bigger than an average car. For a nuclear power plant, that's incredibly tiny, but for a space system, it's still pretty big. Rolls-Royce is actually one of the companies leading the way in space-based nuclear technology. Most people probably only think they make super luxury cars, but Rolls-Royce has been manufacturing nuclear reactors for the British Navy submarines for over 60 years now, so they have a lot of experience in the field. Their current microreactor design is aiming to produce between 50 and 100 kilowatts of electricity, which on the high end would be enough to power a small factory or a few average houses. So just one of these would be plenty to get us started with a small engine.
We just got up. I'm gonna make some hot dogs for lunch. It's 1:20, but who cares?
Nice snake, Chris. Oh, yeah, that's something. And how exactly would I do that, Chris?
Just be chilling in the pool one night.
I think I'll close the pool cover. Your car's here. I gotta go. Love you. You seem tense. Can I book you a massage and a cinnamon scrub?
Another super scrub.
Okay, I'm up. I'm gonna step down and have some lunch. What's some lunch? You can lie, Tyler. I could also tell you can also lie a little. You can lie, cannot lie. I'm not going to lie.
Just like that. Well, we got a double header today here in Archive Land. So first up, that on TV box behind me needed a little work. So the first half-ish of today's episode will be devoted to me trying to clean and fix it up a little. And of course, this being archive, testing it out as much as we're going to these days anyway. But then after that, since we're in non-cable pay TV mode, I've managed to dig up another batch of largely forgotten pay TV channels. Nothing here is quite as insane as Telefirst, but and I finally added in the Manhattan cable TV box, which I did a Ben's junk on at one point, and I think I featured one other time. But now I need to find an on-TV box, and hopefully I can stack it on top of the Manhattan box and maybe have it all fit. Well, it's taken me over 6 years, but I finally managed to get my hands on a not destroyed on-TV box. Yes, it was a flea magazine. Anyway, here's what I know about this particular box. Even though on TV is most closely associated with Chicago, which I think is partially my own doing, on TV actually launched in Los Angeles in 1977 via KBSC. My on TV box comes from that market. It was produced by Oak Industries, who owned on TV, and was manufactured on December 12, 1981. Admittedly, when I first got this box, I just gave it a quick half-assed cleaning.
so it would be presentable at a distance at least. But this box is actually not in such a great condition. It's still got some gunk on it in some spots. It's got some nicks and scratches on its face. The wood paneling is coming off. The top right corner got bashed in at some point. And it only has 3 out of its would-be 4 rubber feet. I've actually been using a small stack of pennies to prop this thing up for these last few episodes. Now, initially, I wanted to take this apart just enough so I could, just take a look around and also clean out any cobwebs or anything else that's built up in there over the years. But as it turns out, the screws on the bottom of the unit, which holds the whole thing in, match, are some kind of presumably proprietary screws.
Okay.
They appear
So-
to be some sort of odd inverted tri-wing screw.
Yeah, I know, but I'm gonna work on that later on today. So we're gonna have some lunch, and that's it.
But when I
Girls' night.
Disclaimer. This video series does not use or encourage AI voice acting. This project is made with love from Jordy Torchy and their voice actors. If you want to use AI, that is right there, kids.
Girls' night. Stuff tonight.
Would work. Dogs.
Okay, I'm gonna eat some lunch. A late lunch. Now do something else.
Can you make one fingernail red? Oh, like the trick where the ring fingernails a different color? Sure. I wish we had white fingers. You're telling me. Sure. What do you think?
It kind of looks like you're flipping the bird.
The closest thing to swearing that we have.
Okay, it's cute. Yeah, but I'm gonna watch something else. Maybe Funny Time for Channel actually did good. Oh, there it is.
Astronauts all love it. So, NASA tried to ensure space food is as much like food as possible. The process begins.
Oh, I got. Oh,
We're making spaghetti with meat sauce.
It's only when it gets back to the NASA lab things change.
Thank you.
Spaghetti in mid-film is just one of 250 options that the astronauts can choose from. And all of them are forensically.
I'm 6, almost 7, and I take my running very seriously. That's why I drink Organic Kid Shake. It has vitamins, minerals, and protein to help me grow. I start my day the yummy way with organic.
Actors on payroll.
Hey guys, I'm Will from Texas. We are here at Johnson Space Center in Houston at the Space Food Systems Upgrade. I'm here with Vicki Claris, who's basically in charge of everything that the astronauts eat on the space station.
Well, at least U.S. provided food on the space station.
Okay.
We do have our Russian colleagues who are providing about half of the food that goes to the space station.
And they're separate but equal.
Separate but equal.
Picture this, 8 months in space, 250 miles above Earth, with zero access to fresh food. Right now, astronauts aboard the International Space Station are eating meals that were prepared months ago on the ground. How does NASA feed its heroes in the most hostile environment imaginable? The staggering challenge. The numbers alone will blow your mind. Every astronaut needs roughly 1.8 kilograms of food per day. That's nearly 4 pounds. For a typical 6-month mission, one astronaut requires over 360 pounds of food. Now multiply that by 6 crew members rotating through the station, and you're looking at tons of food that must be prepared, packaged, and launched into orbit. But here's what makes this truly incredible. NASA doesn't just throw freeze-dried packets into boxes and call it a day. They're preparing restaurant-quality meals that must survive months of storage. The violent shaking of a rocket launch, temperature extremes, and the vacuum of space itself. And when astronauts finally open those packages 250 miles above Earth, the food needs to taste good enough to keep morale high during one of the most stressful jobs humanity has ever created. The planning starts nearly 2 years before launch. That's right, the chicken teriyaki an astronaut eats on day 180 of their mission was being developed and tested while they were still training on Earth. This isn't meal prep. This is engineering food for survival in an environment where everything we take for granted simply doesn't exist. Think about what happens when you skip breakfast or eat bad food for a few days. You feel tired, irritable, unfocused. Now imagine that happening 250 miles above Earth while you're conducting critical experiments, maintaining life support systems, or performing spacewalks where one mistake could be fatal. NASA learned decades ago that keeping astronauts well-fed isn't just about preventing hunger, it's about maintaining peak human performance in the most demanding workplace ever created, the menu development process. NASA employs an entire team of food scientists whose sole job is making space food that astronauts actually want to eat. These aren't your typical chefs. They're combining culinary arts with chemistry, physics, and psychology to create meals that work in zero gravity. The process begins with the astronauts themselves. Before launch, each crew member sits down for extensive taste testing sessions at NASA's Space Food Systems Laboratory in Houston, Texas. They sample hundreds of different items, rating each one on taste, texture, and appearance. The goal is to create a personalized menu that prevents what NASA calls menu fatigue, the dangerous loss of appetite that happens when you're eating the same foods repeatedly in a stressful environment. Here's where it gets fascinating. Astronauts can't just pick their favorite foods and call it done. Every single meal must meet strict nutritional requirements. NASA nutritionists calculate exact calorie counts, protein levels, vitamins, and minerals needed to keep the human body functioning in microgravity. Too little calcium and bones weaken. Insufficient vitamin D and immune systems fail. The wrong sodium balance and fluid shifts in the body become dangerous. The average male astronaut needs about 2,500 to 3,000 calories per day. Female astronauts typically require 1,900 to 2,200 calories. But these aren't just any calories. The macronutrient balance must be precise. Roughly 15% protein, 30% fat, and 55% carbohydrates. Every meal is calculated down to the gram to ensure astronauts receive exactly what their bodies need. But NASA discovered something